All right, here is part 2. Okay, so number 15. Answer the following for each graph. Increasing or decreasing? Number of turns. Identify the number of real zeros and the end behavior. So you just have to look at each graph and identify where there's increase and a decrease. Well, I see increase here, so I'll draw an arrow. There's a decrease here, draw an arrow, and another increase here, so I'll draw an arrow. And that's it. And then how many turns are there? Well, it's where it goes from a positive to a negative slope, or when it goes from a negative to a positive slope. In other words, where it goes up, then down, or down, then up. And so it says, how many turns are there? Well, there's one there, and one there. So there's 2. Identify the number of real zeros. Well, again, remember, real zeros are also the x-intercepts. So I've got crosses right there at the origin. And we'll run right there, off to the side there, and then it does it once more there. Okay, and then the end behavior is just what is our graph doing as it goes to the left, and what is our graph doing as it goes to the right, as far as the x values go. Sorry, as far as the y values goes, not the x values. Well, as it goes to the left, it's going off in the negative direction. And it goes to the right, it's going in the positive direction because it's going up. Okay, now the next one. First, increase and decrease. Well, it goes increases here, decreases there, increases again here, and then decreases again here. So we've got 2 increases and 2 decreases. It makes a turn here, makes a turn down here. So the first one, let me just say it's going from positive to a negative slope. This one's going from a negative to a positive slope. And then there's one more turn here going from a positive to a negative slope. Okay, identify the real zeros. It looks like it only crosses it once here and once here in the negative area of the x-axis. So we got 2. And then end behavior is that as it goes to the left, it looks like it's going in the negative direction. And as it goes to the right, it's also going into the negative region. And that's it. Okay, next one. Number 16. If f of x is this equation here, which happens to be in vertex form, what is the value of h and k? Well, we looked at this a minute ago. So the value of h and k is this value here and this value here. Remember, x is a liar for the x value. So it's not negative 4, but positive 4. And then 3 is our h, k value. So in other words, you could say h is equal to 4 and k is equal to 3. Alright, let's go to the next one. Now it says list all the graphs that have a negative behavior to the left and the right. So which ones, as it goes to the left, have a negative behavior, and as it goes to the right, also have a negative behavior. Okay, so looks like C here has a end behavior to the left and right. E as well, because it goes down here and down here. And H as well, because it goes down here and down here. Alright, so we would put C, E, and H. List all the graphs that have 3 turns or more. Okay, well it has to turn more than 2 times. So let's see, looks like C again, so because it turns there, there, and there. And looks like E again, because it turns there, there, and there. And it looks like, oh wait a minute, look at this one. Let's see, how many turns are on this one? We got one there, it's kind of hard to see, another one there, another one there. That has 4 turns. So that we have to include as well, because it says 3 turns or more, not just 3. So that would be graph C, E, and F. Okay, now the next one says we've got to list all the graphs that have opposite end behaviors going from positive to negative and from negative to positive. So, if you think about it, those are really the ones that are, they have an arrow that's pointing down on one side and an arrow that's pointing up on the other side. So basically they're opposite each other. And so that would be A, because it starts in the negative and goes to positive. D starts in the positive, goes to negative. F starts in the positive, goes to the negative. And G, going down to the negative on the left, up to the positive on the right. And that's it. So it'd be A, D, F, and G. Okay, let's go to the next. Okay, so we're going to solve systems of equations here. So let's start with this first one. Now the first one, actually, you know, let me tell you, I'm going to solve this number 18 by substitution. I'm going to solve number 19 by elimination. So I'll show you two different ways. So this first one, to solve by substitution, I have to take one equation and set it equal to a variable, and get basically by the variable by itself. So what I'm going to do is I'm going to take this first equation, I'm going to set it equal to y. In order to do that, I'll have to move some things around. So I'll have to subtract 5x from both sides. That goes away. And then we have y on the left. And now we have negative 5x minus 19. Now what I can do with this is substitute it where y is over there. Now, just to let you know, that should be a negative right there. And that's my fault, that little typo. So it should be negative 2x minus 10y equals negative 2. Okay, so I'm going to substitute what I just solved into the other equation. I don't know why that goes away. So now I have negative 2x minus 10 times what I just found over here. So I'm going to put that here. That because y is equal to all that, so I can just substitute for y. And now I can just solve for x. So now I have to distribute. So let's rewrite the negative 2x. And negative 10 times negative 5x is positive 50x. Then negative 10 times negative 19 is positive 190. And then that's all equal to negative 2. So now I got to combine like terms. So these two here, negative 2 plus 50 would be positive 48 plus 190. And now I need like terms on separate sides. So I'm going to get rid of this 90 by subtracting it from both sides. Okay, so now we have negative 2 minus 190. So now we get negative 192. And divide both sides by 48. And then x, putting out our calculator here. So let's see, negative 192 divided by 48 is negative 4. So x is equal to negative 4. But we're not done, because remember, when we're solving a system, that means we need to find more than one variable. So I got to find the y variable as well. In order to find that, I just take my x variable and plug it back into one of the original equations. It doesn't matter which one. So let's do it in a new color. So now I'm going to take the 5x plus y, and I'm going to plug in the 4 there. Plus y equals negative 19. And now I have negative 20 plus y. And then add 20 to both sides. And y is going to be equal to 1. So if x equals negative 4 and y equals 1. Okay, let's go to the next one. Now this one I'm going to solve by elimination. In order to do that, I have to eliminate one of the variables. And I'm going to choose to eliminate the x variable. So in order to do that, I need to make them opposites. So I'm going to make this 5x and the 3x 15, and I'm going to make them opposite, so one will be positive, the top one will be positive 15, the bottom will be negative 15, so I have to do times 3 and 5, and then multiply it all the way through. So now 3 times 5x is 15x, 3 times 4y is 12y, 3 times negative 2 is negative 6, and then the bottom equation, 5 times negative 3 is negative 15x, 5 times negative 7y is negative 35y, and 5 times 15, that is 75. Just make sure real quick. 5 times 5, carry the 2, 75, yep. Okay, now we know that eliminates because the 15x minus 15x. And then what we're doing is basically combining the two equations. So now it's 12y minus 35y, which is going to be negative 23y. And then negative 6 plus 75 is going to be 69. Divide both sides by negative 23. And 23 goes into 69 3 times, but there's a negative, so it'll be y equals negative 3. And again, we have to plug that into the other equation to find the x value. So I'll take the first equation, 5x plus 4 times y, and I'll plug in the y value, 3, there. So again, that goes there. And then multiply it all the way through, 5x. And then, that's going to be a minus, because 4 times negative 3 is minus 12. Then I have to add 12 to both sides. That goes away. Got 5x. And then negative, that should be negative 2. Then negative 2 plus 12 is going to be 10. And then divide both sides by 5. And we know that x is equal to 2. So y is equal to negative 3, and x is equal to 2. Alright, now let's go down here to factoring. Now this first one, factoring is just reverse FOIL. So you say in your head, you think in your head, what do I, first you put your x's here. As long as that first term right there in the front, as long as it's 1, you can just do the quick reverse FOIL method. If it's bigger than 1, you can't do it this way. So you can just write your binomials, put x in the front, x on the other one, and you have to say to yourself, what do I add, what two numbers do I add to get 11, but multiply to 28? Well, that'd be 7 and 4, and they're both going to be positive because 11 and 28 are both positive. Or you can do it with the magic x. Put the 28 on top, 11 on the bottom, and do the same thing. What do I add to get to 11 and multiply to get 28? Well, 7 and 4. Okay? And there's your all factored out. Now this next one, like I said, if that leading coefficient is bigger than 1, we can't do the regular just reverse FOIL magic x. You got to do 2 steps. So you're going to use the magic x, but now you're going to multiply a times the c value. So a times c, which is 30, and then you're going to put the b value on the bottom. But you do the first step is still the same. What do I add to get 17, but multiply to get 30? Well, 15 and 2. Okay, so now after you find those two factors, you are going to do the box. And that's why we call this the x box method. The first term in the top left box is going to be the 3x squared. The bottom right is going to be the last term, and I'm getting that from the original equation. And then what you do is you take your terms that you found, the 15 and the 2, and that becomes 15x here and 2x here. And so whatever those terms are, they just become that number with an x next to it. Now you just have to, it's kind of like a puzzle. You got to figure out, what would I multiply to get 3x squared? Well, it'd be 3x and x. But then you got to figure out, where am I going to put it? So let's put the 3x here and the x here. And then you say to yourself, what do I multiply times 3x to get 2x? Well, that'd have to be a fraction. So that doesn't sound like it would work very well. So let's try to see if we can do it without getting fractions. So instead of putting the 3x on the side, let's put it on the top and the x over here. Now what can I multiply times x to get 2x? Well, just 2. So that comes out kind of clean. And then the bottom here, what I multiply times 3x to get 15x? Well, 5. Well, that seems to work a little better. So now those are going to be my factors. So now you take the top one, that becomes the first factor, and the one on the side becomes the second one. And there you go. Oop, in the parentheses. Okay, and that would be your answer. Okay, so now let's go down to this, solving some quadratics. Okay, so now we need to name the roots of the following equations. So in other words, what do I have to plug in here and here in order to make it equal 0? Well, the nice thing about this one, it's already factored out, but you may have to factor it out. But in this case, it is factored out already. So we can just figure out, what do I have to plug in there to make everything equal 0? Well, for the first one, all I have to do is plug in 0, because 5 times 0 is 0, and then 0 times anything is 0. But for the second one, I would have to plug in a positive 4 there in order to make that 0, because 4 minus 4 is 0. So our roots are 0 and 4 for the first one. Okay, so now the second one we actually are going to have to factor out. Okay, so let's make our binomials. And I know that when I have a perfect square in the front, which is 1, and a perfect square on the end, which is 9, and there's a minus in the middle, I know that simply all I have to do is take the square root of the first one, which is 1, and that becomes our first term next to x. And I take the square root of the second one, and that becomes the second term in each parentheses. And then it's going to be plus and minus. And if you look in your factoring section in your notebook, you'll find that there. Okay, so, and if I go back just to check x times x is x squared, and then negative 3 and positive 3 cancel each other out, so there will be no x term. And then I take the last two, 3 and negative 3, that will become negative 9. So that's how it works. Okay, so now I just say, well, I plug in here and here to make this 0. Well, the first one I would plug in negative 3. The second one I would plug in positive 3 to make it 0. So those are my two factors. Okay. Next one, 22. What does a positive discriminant tell us? Well, if you guys look at your notes on the discriminant section, a positive discriminant tells us that we're going to have 2 real solutions. And I'm going to write it shorthand like that. Then, what does a negative discriminant tell us? Negative tells us we're going to have no real solutions, but we will have 2 imaginary solutions. Okay, then what does a discriminant of 0 tell us? Well, a discriminant of 0 is just telling us that we only have 1 real solution. Okay. Now, what information does the discriminant provide? Oh, let's see. It doesn't tell us the max or min value. I know that. I have to get the y-intercept from the standard form of a quadratic. And then A tells us whether it opens up or down, but we don't have that in the discriminant. So it tells us the number of zeros. How many solutions or x-intercepts do we have? That's what it tells us. Now we have to find the discriminant of this equation here. Okay, so if you remember, the formula for discriminant is b squared minus 4ac. If you don't remember it, use those flashcards to help you remember. Okay, and in order to actually find the discriminant, I need to make sure that this original equation is actually in standard form. And right now it's not, because I have this number over here on the right side of an equation. So it's got to look like ax squared plus bx plus c. So let's rearrange it. So what I'm going to do is I'm going to subtract 12 from this side and subtract it from over here. 7x, and now I have negative 12x here equal to 0. Now I can take a discriminant. And you see how that changes things, because now it's no longer positive 12, it's actually negative 12 that I have to plug in. So now you're just going to plug in those values. So the b is negative 7. I'm not going to make that squared. Then minus 4 times the a value times the c value. Then multiply everything out. Negative 7 squared is 49. And then, let's see, I have two negatives over here, so that means I'm going to end up with a positive number. Then I multiply 4 times 3, then times 12, which is going to be 144. And then I'm going to add those two together. So now 144 plus 49, it's going to be, let's see, 194, 193. And so our discriminant is 193. Now think about, if I have a positive discriminant, what does that mean? I'll go back up here to number 22. Positive means that I'm going to have two real solutions. Okay, so make sure you know how to recognize that. Okay, that was part 2.